Okay, so we are going to look at the beginning of lesson 6 of unit 1. It's on page 17 in your workbooks. What we're going to do is just kind of go through the basics of area and a little bit about perimeter so that we are prepared to talk and discuss on Tuesday. Okay, so it says the area of a rectangle here is base times height. So we're just taking this base and we're multiplying it by the height of a rectangle. Okay, the area of a square, since our sides are labeled S, it's really like taking side squared. So we're taking side times side, okay? Which is kind of like base times height, really. We're just taking this side and we're multiplying it by this side because in a square, all sides are congruent. The area of a parallelogram is also base times height. Okay, so we're taking the base, and then this time we can't say the height is this. That is a no-no. We cannot say that is the height. The height has to be perpendicular, which means that it forms that 90-degree angle. Okay, we've also talked a little bit about an area of a triangle already. Area of a triangle is 1/2 base times height. Okay, so we're taking the base and the height, because they must be perpendicular, and we're taking half of that. The area of a circle is pi r squared, or pi times the radius squared. Radius is equal to r, and d is equal to diameter. So the circumference of a circle is basically like the perimeter of a circle. It's the distance around. Okay, so the circumference of a circle is pi times diameter. Sometimes you might also see it as 2 pi r. And the reason you might see that is because r, if you double r, it's actually the diameter. So 2 times r is really d, which is the same thing. Those are both congruent or both equal. Okay. We kind of already talked about this next step. So it says, what's the difference between perimeter and area? Well, perimeter is the distance around a shape. Okay. And then the area is basically like the how much space that particular figure takes up. So area is I'm going to say area. The shape takes up. So how much space is that shape taking up? That's what the area is. So it says, give 2 examples of when perimeter would be used. So like using in real life. So I would say a good example of when perimeter would be used is putting up a fence. Okay, so a fence around a specific area, that would be perimeter. Okay, another perimeter idea would probably be like putting trim, like baseboards up in your house. That would be perimeter. Okay, and then giving an idea of area, that would be like saying, how much paint do I need to cover a wall? How much area is that? Let's see. Another thing would maybe be, how much grass seed do I need? You have to know the area of the space that you are going to be seeding in order to know how much grass seed you're going to need. Okay, so the perimeter of a square for number 3 here says the perimeter of a square is 44 inches. What is the area of that square? So I'm going to draw a square because I always think it's easier to make sure that you draw And it says the perimeter, so the distance around is 44. Well, with a square, we know each side is congruent, which means all of those need to be equal. So if I know that my area is 44x, and I know I have 4 sides that are all equal, I can take that 44x and I can divide it by 4, because I need to know what each specific side is. So if I divide 44x by 4, 44 divided by 4 is 11, and I leave that x there. Okay, so that means that each of these sides is 11x. So then it says, well, what is the area of that square? So this is whenever you have to use your formula, that side squared. So I'm going to say, well, 11x squared is the same as 11x times 11x. So we take that 11 times the 11 and we get 121. And then we have x times x. And x times x, remember whenever we're multiplying things that have exponents, we have to add their exponents. So there's really like a 1 here and a 1 here, which gives me x squared. So my area of the square would be 121x squared. Okay, for number 4, it's actually opposite. So this time we're given the area, and we need to figure out what the perimeter of the square is. So we know that the area of a square is side squared. We were told that way up here. That's what our formula is. So if I know the area of this square is 48, I'm going to plug that in for area. Okay, and I'm going to say, well, that's equal to the side squared. Now, we know how to solve this because we know how to get rid of that square. You guys with the Pythagorean theorem should already know that we need to take the square root on both sides. And whenever we do that, we get the square root of 48 is equal to s. Now, if you don't have a calculator that does this for you already, what you're going to want to do is you're going to want to break that 48 down so we can get that radical in simplest radical form. So we're going to break that down. I'm going to break it down to 6 and 8. And then 6 can be broken down to 3 and 2, which are both prime numbers. We're going to break 8 down to 2 and 4. 2 is prime, 4 is not, and we can break that down to 2 and 2. Okay, so we need to find our pairs here. We have a pair of 2's here. We also have a pair of 2's here. And then we have this loner 3. So I need to bring a 2 from my first pair out. And I need to bring another 2 out. And then I'm going to leave that loner 3 underneath the radical. So I end up with 4 root 3 is equal to s. But we weren't told to solve for one side. We were told to find the perimeter. So if we want to find the perimeter of this square, 4 root 3 is going to be on 4 sides of my square. It's going to be on every side of my square, which means I have to take 4 root 3 and add it together 4 times. I can also, since I'm doing it by 4, say 4 times 4 root 3. I have 4 sides, and each side is 4 root 3. At this point, you just want to say 4 times 4, which gives me 16. And then I still have that root 3. So my perimeter would be 16 root 3 feet. Okay. Moving on to number 5. So So with number 5, it says the diagonal of a square is 10 root 2 meters. So I'm going to go ahead and draw my square. Then I'm going to draw my diagonal here. Okay, and we're told that that diagonal is 10 root 2. So if that is 10 root 2, what we are going to do to find the area and perimeter, we need to know what the sides are. So this is kind of going back to the Pythagorean theorem. Because we know all of our angles in a square are 90-degree angles. And we know all our sides are congruent. So if I look, let's see, if I look at this portion of my square, I have a right triangle, and I can solve for x to see what my side lengths are going to be. So I have a leg squared plus another leg squared is equal to that diagonal or the hypotenuse squared. Okay, so I end up with x squared plus x squared, which gives me 2x squared is equal to, and I'm going to do this down here, the 10 root 2 times 10 root 2, because I need to figure out what that is. So 10 times 10 is 100. And then root 2 times root 2, that's going to be root 4. And the square root of 4 is 2. So we're going to say 100 times 2 gives me 200. So that 2x squared is equal to 200. Okay. From there, we're going to solve this like we have been. We're going to divide by 2 first, which gives me x squared equals 100. And then I'm going to take that square root because I need to get rid of that x squared. And I get x is equal to 10. Which means instead of each side being x, each side is going to be 10. So now, in order to find the area and the perimeter, area is equal to side squared. So area is going to be equal to 10 squared. And that means 10 squared is going to be equal to 100. So my area is 100, and then we're going to say meters. Oops. Meters squared. Anytime we have area, we take our units and squared. And then the perimeter is equal to 4 times whatever our side length is. So 4 times 10, which is going to give me 40 meters. Now, perimeter, most of the time, is equal to all those sides added together. So we just take 10 plus 10 plus 10 plus 10. The only reason I changed that up and did 4 times 10 is because we are talking about a square. So that means every side has to be 10, and there are 4 sides. So that's why I took the 4 times 10. All right, let's look at number 6. It says the area of a rectangular patio. Hold on, let me erase some stuff here. Is 7 square yards. And the length is 1.5 yards. So it's saying, what is the patio's width? So we are talking about a rectangle. And if we look back up here, the rectangle is base times height for the area. So it says the area of the rectangle, I'm actually going to write this out. It says the area is 7 square yards. So area is going to be 7. It also says that the length is 1.5 yards. So length can also be your base or your height. Okay, so length times width is kind of the same thing. So we have area equals length times width is the same thing as that base times height. So I'm going to say that the length is B, which is 1.5. And I'm going to go ahead and write that as a decimal. I'm going to say 1.5. And then we're going to say H, which is also like our width. Okay, which is what the first question is asking. It says, what is the patio's width? So if we have this, we have 7 equals 1.5 H. In order to solve for H, we need to get rid of that 1.5 by dividing it out. So if we divide that out on both sides, 7 divided by 1.5 gives me 4. Let's do the 6 repeating. Let me make sure that's right. Yep. So 4.6 repeating, that just means whenever it's in your calculator, it's going to say 4.6666666, and then it's going to have that 7 at the end. Okay, and we're going to say that's equal to H or W if we use the length times width. Okay, so we have 4.6 repeating. And we're going to say yards because that's what our units are. Then it says, well, what is the length of the diagonal of the patio to the nearest tenth? So we have that rectangular patio. Okay, we've already found that our length is 1.5 yards. And our width is, well, this doesn't look right. Let me redo this. It doesn't really match our picture, so hold on one second. So we have our rectangle. We have 1.5 as our length, and then we have 4.6 as our width. Okay, so it says, well, what is the length of the diagonal? So we're going to have to find the diagonal from corner to corner. And since we have a rectangle, we should know that all angles in a rectangle are also 90 degrees. Okay, so if we have that, and you look at this side of our rectangle here, this half, that's a right triangle again. So again, we can use Pythagorean theorem. So we're going to want to say that 1.5 squared, because that is a leg, plus, I'm going to go ahead and round that and say 4.7 squared is equal to that diagonal, which is our hypotenuse, x squared. So we have 1.5 squared, which is 2.25. Then we have 4.7 squared, which is 22.09. And that's equal to x squared. Let me make sure here. Yep. Okay, so if we add the 22.09 and we add the 2.25, we get 24.34 is equal to x squared. And our last step would be having to take the square root on both sides. So if you take the square root of that 24.34, you get 4.933 is equal to x. And in the directions it says to the nearest tenth. So we're going to say 4.9 is going to be to the nearest tenth. So it's going to be 4.9 yards for our diagonal. Okay. I think we are going to go ahead and stop here. So we just did page number 17, but we're going to go ahead and stop here because I just wanted to get you an idea of what we're going to be working on the next few days. So if you have any questions, please come with those